Let's now understand the concept behind the softmax operation in attention, represented by Q multiplied by K transpose and divided by the square root of D sub K. We'll go through what each term means and why multiplication and division are used in this formula. Here Q stands for the query, which represents the current input token or word that is searching for relevant information. This query is the prompt the model is trying to process. K represents the key, which holds potential reference points from either the input sequence or stored memory. Essentially, it's what the query compares itself against to find related information. When we multiply Q by K transpose, we're performing a matrix operation to calculate similarity scores between the query and all the keys. The transpose of K is required for this multiplication because the dimensions must align for a valid matrix product. The result of Q multiplied by K transpose gives us a raw similarity score that shows how closely each query relates to each key. However, this raw product tends to grow with the size of the vectors, as the vector dimensions increase. For example, when each word is represented by 512 values, the magnitude of these similarity scores can become very large. This creates a problem because the variance between different word representations also grows, which can make the attention distribution unstable. To balance this, we divide the result by the square root of the key's dimension, noted as the square root of D sub K. This division normalizes the similarity scores, keeping the scale consistent and preventing extremely large values that could distort the gradients during training. In simpler terms, multiplying Q by K transpose measures similarity, while dividing by the square root of the key dimension stabilizes the values by reducing variance. You can think of this as a form of normalization similar to cosine similarity, but without the explicit normalization step. So Q multiplied by K transpose gives the core similarity measure, and dividing by the square root of D sub K ensures those scores remain within a manageable range. This helps the model maintain stable gradients and better focus during attention calculation. I hope this explanation clarifies why we multiply and divide in this equation.